I raised twins back on some of them.
If there's a wall here, do we need to build a fence here? No. That would be like if Miss Foster's room got built first and we want to build our classroom. How many walls do we need? Three, because this one's already built, right?
We need 4 walls, so only 3 need to be built though.
Only 3 need to be built because we have that wall already there.
It's already good.
Okay, so now we have L, and it wants to determine the length of the dog park L in terms of width.
L equals 1,000 minus 2,000. Oh, no.
Now, if we want to find what L is, do we know what L is? No, but we know what W, what the width and the length are, right? They're just W and L. Now, how can we find an equation for L? If we add all of these up, how much is it going to be? 1,000. So if we have the length plus the width plus the other width, and it equals 1,000, what are 2 W's adding together? 2 W. So if we want to get L by itself, what do we have to do? 1,000 minus 2 W, because we got to subtract W on both sides. So we have L is equal to 1,000 minus 2 W. Okay. Now it wants us to write a function A of W to represent the area of the new dog park as a function of the width W. Does this function have a minimum or a maximum? Explain. So first we're going to find our equation for A of W. So if we know the width is W, right? So we're going to write down width as W. And what is L?
1,000 minus 2W.
1,000 minus 2W. Okay. Now, how can we find the x-intercepts of this function?
Put it in a graph.
Put it into the calculator and graph it, right? So we put it in our calculator. And then make sure that your window is this right here in your graph. So graph it, window, 0, 600, Y minimum, 150,000, and then graph it. You should get a graph like that. And then how can I find the x-intercepts? What can I do?
Trace.
Trace. And just go where? Till Y is what number? 0. So I go down here and it tells me what? What's my X value? 0. And I know my Y value is 0. So then it hits at another point, doesn't it? So let's go over and find that point. All the way over. Is there a faster way? Second, trace, 0. Left bound, yes. Then go off our graph. And it tells you. And what is it? 500. So you have 500, 0. Sorry. So we have 500, 0. Now, what does this mean in our problem situation? Width is either 0 or 500. So let's look at this. If the width is 0, so this is our little dog park here, that the existing one. And we want to build this new one, right? And we have no width. And we have 1,000 for our length, right? That means we build that fence right there. What's the problem with that? Is there any room for our dogs to play in this little tiny area? That's a fence beside a fence that just goes 1,000 feet, right? That's not going to work for our dogs. Now, what about if we have our existing one here and we have 500 for each width, right? So we build 500 feet, there's no length, and then we have 500 feet this way. What's the problem with that? Still no room for the dogs. That's another fence beside a fence, right? So can we do that? No, we can't do that. So what should the dimensions of the dog park be to maximize the area?
20 by 50.
20 by 50. How did you get that?
I knew 1,000 divided by 100 was 10.
Okay.
So I went up to 20.
Mm-hmm.
1,000 divided by 20 is 50.
Mm-hmm. Okay, there is a more accurate way. How can you do it? Because it won't always be that easy. How can you do it? Graph the maximum. So second trace maximum. And we got to go to the left side of it because there's different each way. So enter and enter. So what is it? 250. So it's going to be 250 for our X, right? Do we know what our length is? Because that's for our width, right?
Length has to be 500 then.
Why does length have to be 500?
Maximum.
Equal 1,000. So you have 1,000 divided by 250. Is that right? No. Why is that not right?
You divide it.
You divided. What am I supposed to do?
Subtract W.
Plug it back into my equation because this is equal to 2L, right? This is equal to L. And I want to find L in terms of W. So I do L equals 1,000 minus 2 times 250. And what does that give me? L equals 1,000 minus what? 500. And then what is L? 500. So to maximize, we have W equal to 250 and our length is equal to 500. Couldn't see that. And that is how we maximize how much area we have for our dog park. What?
It'd have been way easier if we just went out and looked at the other fences.
What do you mean? Go out and look at the other thing.
Because we knew the L, all we had to do was measure the existing dog park, that already existing fence. All we had to do was measure that and we would have had the 500. Already,
But would that maximize our area?
but we already have the 500, so 250 and 250.
Well, if they
Good
didn't know what
point.
to maximize.
But we don't know what that is. And we're in this class and we can't go outside and measure it. We can't go on that field trip. We are engineers designing this. And we're not given dimensions.
Eyeball it.
That picture is not drawn to scale, so
Not at all.
the existing dog park might have sides that are 600 feet. It might be a huge existing dog park, but we only have 1,000 feet of fence. So it might be a small little square that we put on the end. It might
Yeah,
not be.
could be.
It might not be like that. Yeah, it
Like
might
that.
be much bigger. But that's a good question.
It's good. It's a good thought. All right. So. Got your books.
Smarter.
Now, today, we're going to be dealing close with vertical motion. Do y'all remember dealing with vertical motion yesterday? What was the key thing that you learned?
It's going
It's a
up.
parabola.
Parabola, but what did we use as our example? A pumpkin being catapulted, right? So this is the same equation that we use for the catapult. So we have y equals -16t squared plus v sub o of t plus h sub o. Now, why did people build catapults?
To attack castles.
To attack castles. Why did that matter?
Walls.
Walls.
War.
You want to knock down the other person's walls so that you can go in there, and raid their castle and take over the land, right?
My castle now.
Yeah, but
Do people still build catapults?
Yes.
Yeah.
You ever heard of pumpkin chunking?
Yes, I watched it.
Have you watched it?
Let me guess.
Has anybody ever watched it other than Foster?
what's a
No.
chunky?
Well,
I
I found
know
out.
Angry Birds, like, oh wait, that's a sunshine.
This is an actual contest that they do.
This
They
is
take
just so much fun.
catapults.
This is an annual
they sling
tradition. It goes on
like
everywhere. But
medieval times.
in this particular case, this is in southern Indiana. This is the pumpkin chunkin competition. And it
It's who
kicked off
can
the
throw
Harvest
it the
Homecoming
farthest.
Festival in New Albany.
They use a gravity-powered launcher, catapulting those pumpkins to a target about 100 feet away. 36 teams are down there competing after building their own launcher.
It's something different that you don't see every day. I'd never even heard of pumpkin chunking until we started ours 5 years ago. So I think everybody's super excited to see it happen.
And we've been talking, is it pumpkin chucking or pumpkin chunking? And she clarified it. She called it chunking.
And then chuck in. You know, if you go online, it says chuck in. I mean, whatever. You're
Right.
throwing the pumpkin.
So this is still
Those
something that
pumpkins,
happens
careful.
to this day. They build catapults like they did in the old day out of wood. It's still going. But anyways, so it is pretty cool to see that that actually is something that actually still happens. So if you remember from yesterday, what did the Y replace? What did Y stand for? I know. It was the height. What does T stand for? Time. What does V sub O stand for?
Initial velocity.
Initial velocity. What about H sub O? Initial height. Now, what you need to know is why did the V and the H have a little sub O with them?
Just
None
the
of the
starting
rest-
line.
Like a line.
Shows that it's the starting of it, because is it always gonna have that same velocity as it's traveling? No, it's gonna have that when it takes off. When you throw the ball or the pumpkin and you just throw it and you release it, it's gonna have that velocity at that time, but then it's gonna start slowing down, right? So that's just saying that is the initial height and the initial velocity. Now, what you need to know is if y'all are really good today, you take good notes, and you figure out what we're doing, and y'all are good at it, we can go outside tomorrow and throw tennis balls to see who can throw the best. So y'all want, you've done points. What do you point now? Ben, you think Ben's gonna win?
No, Ben sucks at math, so like, no.
It's not
I don't
math.
win at
This
it.
is throwing a ball.
No, I
You just throw it straight up and see who can get it to stay in the air the longest. Okay, we're gonna get back to this, because that doesn't matter if you don't pay attention and learn this. So if you don't learn this, you don't get to go outside tomorrow.
We have to laugh about it.
You do have to do the math about it. No, there's no Excel. It's just learning what we're doing. Pay attention, take notes, and learn what we're doing. So number one, you throw a ball. And it takes 4 seconds to land. Part A says, how fast feet per second did you throw the ball? So how fast did you throw the ball? We have an equation we can use?
The one you showed us.
The one I showed you. How are you gonna plug this in? What do you think the 4 is gonna go in for? The time, so T. So what do you think is gonna go in for Y?
We have to find that.
We have to find that. But do we know the initial velocity? That's what we're trying to find, right? So if I want to know the height, if I want to find the initial velocity, I can tell you at a certain time, it's going to be 0, right? The height is going to be at 0. And then the -16. And then what goes in for T? 4 squared plus, what is our initial velocity? We don't know. We're trying to find that, right? And what's it going to multiply by? 4 plus, what is our initial height? Let's see. That is when you release the ball. So, we're going to say
5
6
foot.
foot.
6 to 7 foot.
We're going to say 6 foot just for simplicity, because we're going to say I'm throwing the ball and I'm closer to 6 foot than 5 foot. So we're going to say about 6 foot is when I'm releasing the ball. What are you laughing about? You shaking your head no. Just then. Uh-huh. That's what I thought. Now, can we solve to figure out how fast we threw the ball? Of course. Of course we can. Y'all are experts at solving for one variable, right?
Yeah.
So let's do that. By the way, where did this -16 come from?
Up there.
It comes from up there, but why is that in there?
Because you're throwing it upwards and it has to go
It has
downwards.
to go downwards, and what brings it down? Gravity.
That's
Okay,
gravity.
wait a second.
Why do you think it's negative?
Because it's coming down.
But what is gravity? It's like 32.
9.8 meters per
32
second is
something.
gravitational force.
Now,
Newtons.
I don't know. I don't even know that.
Newton's
But
law.
anyways, if you have
Laws,
a bowling ball and a pebble, and you drop it, which one's gonna hit the ground first?
A ball and a pebble, same time.
At the same time. Why is it the same time?
Because
Gravity acts the same on every object. Gravity acts the same on every object.
Because this math book and this pencil will hit the
but they
ground
went
at the
at
same
the time
time.
because everything.
They'll hit the ground at the same time.
No, yeah,
Because now, you figured out that Galileo, I think it was, in the Leaning Tower of Pisa, he went up to the top of it and he dropped, we're gonna draw stick people because I'm not good. He dropped a little pebble and a big boulder off the top of the tower. And he figured out what? They hit the ground at the same time. They both hit the ground at the exact same time. Which is why that's the same, no matter what, it's gonna stay -16 because they have the same gravity on. It may have been, I don't know. I'm not a history teacher. I don't know. I'm not a history teacher. Some guy, we'll just say some guy dropped the ball. Yes,
There has to be a resistance, which makes it all different.
they fell at the same. They hit the same at the same time.
So the axis of every object outweighs much.
Henry, we're pretending we're in the forest.
Okay, we're gonna get back to this. Sidebar over. Now, how can we figure out what V is? What do we have to do? Solve it. So we gotta simplify, right?
Yeah.
So type this into your calculator. -16 times 4 raised to the second power, 4 squared. What does that come out to? -256. So we have 0 equals -256 plus V sub O and I'm gonna write the 4 out front. Can I do that?
Yes.
I can, because it's just multiplying. You can flip flop multiplication, can't you?
Can we just go ahead and add this?
That's what I was about to ask. Can we add the 6 to the negative 256? We can, because that's like terms, right? So that's 0 equals what? Negative 250 plus 4v sub o. Now, if I want to solve for v sub o,
Divide 4 from both sides.
do I divide 4 or do I subtract first? Or do I, well, I said that wrong. Do I get rid of this subtracting or the multiplying first? You get rid of the subtracting, so you have to add. So if I add 250 to both sides, it cancels out this side. And what's it leave on this side? 250, because 250 plus 0 is what? 250. And it cancels out that negative 250, and you get 4v sub o. Now we divide by 4. So what is 250 divided by 4? 62.5 equals v sub o. And what did it say we were throwing at? What per what? Feet per second. So we have 62.5 feet per second. Is that fast? Can we tell feet per second?
No,
What do we know?
miles.
We know miles per hour. If I were to tell you something's going 20 miles per hour, is that throwing very fast?
No,
No. What do professionals throw at?
anywhere from 95 to 100.
90? So if I say you threw it at 20 miles per hour, you're gonna say what? It's kind of slow. But if I say you throw it at 50 miles per hour, you're gonna say, it's okay. It's still slow, but you're not a major league pitcher. You're just average Joe over here, right? So think about this. We don't know how fast feet per second is. So what do we need to convert it to? Miles per hour. So we have 62.5 feet. And that is divided by 1 second, because that's the same thing as 62.5 feet per second, right? Yes. So then, if I want to get it to miles per hour, I got to get it in terms of miles. So to get it in terms of miles, do I need to divide by feet or do I need to divide by miles to cancel out this feet?
I would
Feet.
have to plug the whole equation in and we did.
Now, we want feet here, which means what has to go up here? Miles. Because we're trying to convert this to miles, right? So we have to keep an equation the same without changing it, what do you have to multiply by? Same thing, but 1, right? Because if you multiply by the same thing, it's on the same side of the equal sign, we can't really do that. We got to multiply by a unique thing of 1, right? So if we have 1 mile, how many feet are in a mile? 5,000 something, it's 5,280. Close, it's 5,280. Now, since we're dividing by the feet, we can go ahead and cross out the feet, right? But now, we got to get, what do we want miles per second? What do we want it in? Miles per hour. So we want to get it up here. Now, to cancel out the seconds, does it need to be on the top or the bottom? The top. So we have seconds up here, and that means we have hours down here. So we have 1 hour, and the seconds cancel out. How many seconds are in an hour?
3,600.
3,600.
That's 60 minutes.
Because you have 60 seconds and 60 seconds in a minute and 60 minutes in an hour. 60 times 60 is 3,600.
Wow, 60 minutes just seems so fast, but an hour is so slow.
Yep. All right. So let's look at this. So now we just have miles and hours. Is that what we wanted? Yeah. So now we got to figure out what this is. So we have, multiply across, we have 62.5 times 3600. And what are we going to divide all that by? 5280. Now, why do I not add in any of the ones in there?
Because
Because we
When
don't
you
need
multiply
that.
something by
Don't
one,
need
it
them.
stays the
It
same.
stays the same, right? So hit enter, and what do we have? 42.6 miles per hour. For an average person, is that pretty good?
Yes.
That's pretty good for a normal person. Well, we're gonna figure out tomorrow which of y'all are all tall. Now, this is the normal conversion rate. Now I want to ask you, how high did the ball go?
67 feet there.
How high did the ball go? Ben says 67.
That's not right.
So B. This is part B. By the way, if you throw a ball up and it hits the ground at 4 seconds, how long is it gonna be till the peak? 2 seconds, because it goes up for 2, it comes down for 2, right? So 2 seconds is key here, right? So we're gonna have equals T. Because that's half of our full time, right? So now we have Y equals, because we're trying to find the actual height, right? So then we have our -16. And what do we plug in for T? 2, because we're trying to figure out at 2 seconds, the peak, right? Now, plus, and initial velocity was in what?
Second.
Feet per second, right? Because we want to keep it in there. We don't want to change that because it's already in feet per second. So we want to keep it that way. Times 2 plus 6.
Can we just like punch that in the calculator?
Can we?
Yeah.
Can. -16 times 2 raised to the 2 plus 62.5. Oop, I messed up.
I did too.
Plus 62.5 times 2 plus 6. And that gives me 67 feet.
That's high for a second.
So Ben, how close were you?
I was perfect.
That's why I started smiling, because you just guessed it right off the bat. 67 feet.
Wow.
67 feet in the air.
In 2 seconds.
Did he throw that pretty high? Think about this.
Yeah.
How tall is 1 story of a building?
Well,
How high is this ceiling?
8 feet.
8 feet. The ceiling's 8 feet. Now, think about this. If there's another floor above us, is it just gonna be 1 inch above us?
No.
No, because it has to have little cross member beams, and that's gonna be about 1 foot, and then you have the flooring and everything else. So that's really gonna be about 2 feet. So you have 10 feet in a story, right? So if you stood next to a 7-story building, you're gonna throw it up about 6.5 stories.
You
That's
could
pretty
throw it
high,
over
right?
the wall at Fenway Park.
Close. So did he throw that pretty high?
yes.
Yeah, he did. So now what I want y'all to do is I want you to tell me how fast and how high. This is your homework, by the way. How fast and how high did Johnny and Sally throw the ball? Johnny, he throws the ball and it lands at 5.2 seconds. Now Sally, she throws the ball and it lands after 8.8 seconds.
Sally's a grown man.
Sally is a D1 athlete going to UT Knoxville for softball. She's going D1.
She sounds like she's 6'4".
We're gonna say, that's a good question. We're gonna say they're about 6 foot tall, 6 feet tall.
It's a giant woman and a small man.
I told you, she's a D1 athlete going to UT Knoxville.
Bro, that's a giant woman and a
That's
small
a
man.
giant.
Not an average size guy, 6 feet.
No, average is like 5'8".
Yeah, no. So either way, he's kind of tall. Now, this is your homework. This is what you have to do. Tell me how fast they threw the ball and how high the ball went. So that is your homework. Go ahead and get started.
Oh, dang
You haven't even, you gotta write, I can't come help you till you write down.
We can do this.
What do I need to write down?
Yes.
And then we just leave it the way it is.
All of you can do this.
So-
Make sure you do it.
First thing you gotta do is do this, figure out how fast it is, convert it to miles per hour, and then figure out how high it went. So you gotta do all that we did first and then second for both of them. Yes,
Here, do we do half of these?
for the height, you do have.